Tomorrow NASA hopes to launch a spacecraft on its journey towards an asteroid, where it will collect and return samples that experts believe may hold the building blocks of life. NASA's OSRIS-REx spacecraft will travel for 2 years to reach Bennu, and plans to return to Earth in 2023. Fitted with sensors, the craft will map out the surface of the asteroid in order to address basic questions about the composition of the very early solar system. Forecasters yesterday said good weather was expected for tomorrow's 7:05 p.m. EDT launch. But NASA has until mid-October to send the SUV-sized spacecraft on its way. It will arrive at Bennu in August 2018 to map the asteroid. "We are going out to explore an unknown world," said Principal Scientist Dante Loretta from the University of Arizona at Tucson. "We're going to map it in great detail. It will be the most well-characterized asteroid in our solar system by the time we're through with it." Thanks to observations from the Hubble and Spitzer space telescopes, scientists already know the roundish Bennu is about 1,600 feet across at its bulging middle and the color of coal, which means it could be rich in carbon. It is thought to have formed 4.5 billion years ago, a remnant of the solar system's building blocks. This means it may still hold clues as to the origin of life on Earth and, possibly, elsewhere in the solar system. The 4,650-pound fully fueled spacecraft will launch aboard an Atlas V411 rocket. It will reach its asteroid target in 2018 after traveling an incredible 4 billion miles through space. Bennu is one of more than 700,000 asteroids traveling through our solar system at the moment and was chosen as the target for this mission because it is the closest carbonaceous asteroid. After a careful survey of Bennu to characterize the asteroid and locate the most promising sample sites, OSRIS-REx will collect between 2 and 70 ounces of surface material with its robotic arm and return the sample to Earth via a detachable capsule in 2023. To capture samples on the surface, the craft will hover over a specific area and will be sent down at a very slow and gently 4 inches per second. It will only be in contact with the surface for 5 seconds as it vacuums up the targeted area. The launch of OSRIS-REx is the beginning of a 7-year journey to return pristine samples from asteroid Bennu, said OSRIS-REx Principal Investigator Dante Loretta of the University of Arizona, Tucson. "The team has built an amazing spacecraft, and we are well equipped to investigate Bennu and return with our scientific treasure." Mapping the surface will not only help scientists sample rocks that could hold clues about the origin of our solar system, but it will also help them better predict the asteroid's future movements and plan ways to deflect it away from Earth. "Our upcoming launch is the culmination of a tremendous amount of effort from an extremely dedicated team of scientists, engineers, technicians, finance and support personnel," said Project Manager Mike Donnelly. The OSRIS, which is short for the OSIRIS-REx visible and infrared spectrometer, will be used to measure visible and near-infrared light reflected and emitted from the asteroid and split the light into its component wavelengths similar to how a prism splits light into a rainbow. "OSRIS is key to our search for organics on Bennu," said Dante Loretta, Principal Investigator for the OSRIS-REx mission at the University of Arizona in Tucson. "In particular, we will rely on it to find the areas of Bennu rich in organic molecules to identify possible sample sites of high science value, as well as the asteroid's general composition. The cutting-edge spectrometer will work alongside the thermal emission spectrometer, which will pick up the thermal infrared while OSRIS maps the asteroid. This collaboration will help the team map the entire surface over a range of wavelengths that scientists feel will be more successful for finding organics and water. This will also help to find the best sites to harvest samples. Because minerals and other material in the visible and infrared spectrum has their own unique signatures, like fingerprints, the team will be able to identify various organic materials. This includes carbonates, silicates and absorbed water that lay on the surface of the asteroid, and all the return data will be used to map the relative abundance of various materials across Bennu's surface. "I can't think of a spectral payload that has been quite this comprehensive before," said Reuter. OSRIS will be active during key phases throughout the mission. As the OSRIS-REx spacecraft approaches Bennu, OSRIS will view one entire hemisphere at a time to measure how the spectrum changes as the asteroid rotates, allowing scientists to compare ground-based observations to those from the spacecraft. Once at the asteroid, OSRIS will gather spectral data and create detailed maps of the surface and help in the selection of a sample site.